2.5 today, and we're going to use the sine and cosine ratios to find out lengths. So I hope you remember from last day that, or the last few days, we have this target angle here. We can label the longest side as the hypotenuse, the side across from the target angle being the opposite, and then the side next to it, the adjacent. And from last day, the sine ratio was equal to the length of the opposite divided by the length of the hypotenuse. And similarly, I guess, the cosine ratio is the length of the adjacent side divided by the length of the hypotenuse. So we're going to use these ratios again today. This time I want to investigate how we can use them to find out length of sides. What would the height of a right triangle that has a hypotenuse of 1 centimeter and its angle of inclination of 60 degrees be? So if I were to draw a picture now, 60 degrees, it's pretty steep. The hypotenuse this time is 1. How would I figure out the height? So once again, in this case, we can use which ratio? Let's think about this. We have a target angle, we know the hypotenuse, and we know this side, which is the opposite side. So if you have the opposite and you have the hypotenuse, which ratio can we use? That's correct. So sine of that target angle of 60 is equal to h over 1. And since h over 1 is just h, it's just equal to sine 60. We can go to our calculator then, type in sine 60, and we're done. 0.866. Okay? Now, how would you calculate the length of this same right triangle? This time, I'm saying that you still have a hypotenuse of 1. The angle of inclination is still 60. But I want now the length. Let me call this L. Notice in this case, I have the hypotenuse, and not the opposite this time, but the adjacent side. So I'd use the cosine ratio. Cos of 60 equals to the height. Oops, not height. My fault. The length of the adjacent side divided by 1. And then, of course, I can just type in cosine 60, and I know the answer to that is 0.5. So it's always half. Okay? So, once again, here's how we can use the ratios to help us calculate the missing sides. So now let's look at some other examples. Once again, these are all right angle triangles, so if you want to write down a right angle, you can. And then we just have to figure out what things we have and find the right ratio. The 14, is that the hypotenuse, the opposite, or the adjacent? I hope you said hypotenuse. It's across from the right angle. And this x here represents this side. That must be the adjacent hypotenuse. Which ratio do we use? Cosine. So cosine of 35 degrees equals to the adjacent side, which is x, divided by the hypotenuse. Once again, we'll cross multiply to solve, so 14 times cosine of 35 degrees is equal to x over 1. I will then use my calculator, 14 times cos 35, and there you have it, 11.5. And then since I have units, write down the units. Cool. You try B this time yourself. Okay? Press pause, then come back and double check your answer with me. This is across from 39, so it's opposite. Opposite over hypotenuse, I'm thinking sine. Once again, cross multiply. Go to your calculator. 5 sine 39. There you go, 3.1 meters. Cool. All right, last one. You can do this on your own if you feel confident, or you can walk through it with me. It's up to you. Here's your choice. Okay, if you feel confident, I would prefer if you pause it and then do it and then come back. Okay, go. Those of you still here with me, here's my angle. Z is across from the 90-degree side, so that's my hypotenuse. The 63 is next to the angle, that must be my adjacent side. So I'm thinking cosine of 20 degrees equals to adjacent, which is 63, divided by the hypotenuse, which is Z. This is the one we have to be a little bit more careful when we do the cross multiplying, because Z times cosine of 20 degrees is equal to 63. So Z is actually equal to 63 divided by cosine of 20 degrees. And now if I use my calculator to figure that out, 63 divided by cos 20, close the bracket, 67. So 67 centimeters. Okay. Alright, so now let's try some curricular competency questions. My favorite ski hill, Grouse Mountain. The beginning ski runs have an average slope incline of 12.3 degrees from the horizontal. Okay, that's interesting. So if I were to draw that out, here's your mountain. Perhaps the runs look like this, 12.3 degrees. Remember, it's the average, so yes, it could go up and down, but it's an average. Okay. The advanced ski run, ooh, has an angle of 20 from the horizontal. Ooh, so much steeper. Maybe I'm exaggerating this. Yeah, there's your average. Suppose Mr. Lee skied down the advanced slope. Yeah, that's me. Whee. Traveling 1,000 meters. So that distance I traveled here is 1,000 meters. And Mrs. Lee, my wife, skis the same distance down the beginner slope. Here she is. The same distance, but down the beginner slope. Who would cover the greater horizontal distance? Now, you might be able to actually visualize this with the actual picture and say, oh yeah, I know who covers the greater horizontal distance. I'm looking at this distance. Definitely Mrs. Lee, because the angle is smaller. That's right. So you got the answer. But now I want you to justify it with the calculation. So can you actually calculate what those lengths are and then prove to me that your assumption is correct? So once again, I'm looking for this length. I'm looking for the length, and I'll do it for Mrs. Lee first. So that would be Mrs. Lee. What angle? 12.3. What ratio do I use? I've got, once again, the adjacent and the hypotenuse. Which one should I use? Cosine of 12.3 degrees. L over 1,000. And what is that equal to? Calculator time. Lots of calculator use in this unit. 977. Okay. 977 meters. That's the horizontal distance she traveled. How about Mr. Lee? Hopefully you can set this up yourself, so I'm going to be quiet now. You try this. I'll call this, I don't know, M. Oops, cosine 20. Definitely 939 meters. Actually, I think it's 0.6, so I should round that to 940. So like you said earlier, Mrs. Lee covered the greater horizontal distance, but now I know why. Mrs. Lee covered the greater horizontal distance. Why? Well, since 977 is greater than 940. Okay, I guess I should write down meters. Done. Yay. If you could do all the calculations yourself, I'm proud of you. Here's another one. See if you can figure this out. I have the diagonal of a rectangle. If you don't know what the diagonal of a rectangle is, here's my rectangle. The diagonal is the distance connecting two opposite vertices, like that. So there's my diagonal. It's 12 centimeters long. And it makes an angle of 32 with the longer side. So that means this angle here is 32. There's the longer side. Is that the only angle here that's 32? Well, there's also a longer side here, so this angle here is also 32. Okay? 32. Okay. Your job is to determine its perimeter and the area. So if you need the perimeter, you need the list of all four sides. And for the area, you need, of course, the length of the two sides, length and width. So ultimately, we have to figure out the length and the width. So I'll call that width W. I'll call this length L. And we have to figure this out. Do you see a right triangle? I hope so. Right here. So, if we want to figure out the width, I think if you're doing the angle of 32, the width represents the opposite side. The length then represents the adjacent side. Alright, and the diagonal, of course, is the hypotenuse. I think I've given you enough information now. You should be able to do this on your own. Okay? So, press pause, like before, work on it, then come back to double check your answer, and then be proud, be confident, and then get to work on your assignment. Press pause. Perimeter will just be the length plus the width, and then we could double it, right? Because there are two of them. 10.2 plus 6.4. Double it. 33.2. And then, of course, for the area of a rectangle, we have length times width. Oops, 10.2 times 6.4, 65.28. And don't forget our units, centimeters squared. Ta-da! There you go. Try these learning activities below.